All right, we're in college algebra today looking at rational functions. Okay? Here's what a rational function is. A rational function is when you're dividing by your variable. Like something like this right here. The numerator could also have your variable in it, but it doesn't necessarily have to. It could be just something like this. Or it could be something like this. But all these are rational functions. When you have a rational function, it gives you a graph that looks like this right here, where you have these asymptotes. See these dotted lines right here? These are asymptotes. This is a vertical asymptote, which is called VA. This is my horizontal asymptote, which I just call HA. Okay? These are your vertical asymptotes and your horizontal asymptote. Now, it's possible you might have two vertical asymptotes, like this one here, two verticals and one horizontal. You'll never have but one horizontal. Your horizontal asymptote will only have one of those. You could have several. Here's one with two. You could have three or four or five or whatever. Now, sometimes you may not have a horizontal. You got one that's a slant, like this one right here, or it's called oblique. This is an oblique asymptote. Okay? But the thing that we're going to be looking at in these rational functions is how to find these vertical asymptotes and these horizontal asymptotes. Vertical asymptotes are real simple. The vertical asymptotes come from the value of x that makes division by 0. Okay, what does x equal to make it have division by 0? An example, that would be right here. Suppose I have this rational function here, x plus 5 is my denominator. Well, that means x equals negative 5. So negative 5 plus 5 would be 0. That would be my vertical asymptote. Okay? Now, horizontal asymptote's a little bit more tricky. There's three cases involved here, where you got d greater than n, d equal n, or n greater than d. Now, what this means is d is your denominator, n is your numerator. And this is the degree in the denominator, and n is the degree in the numerator. So if your denominator degree is bigger than your numerator degree, that means your horizontal asymptote would be y equals 0. If your denominator degree is equal to your numerator degree, all right, that means y equals, you divide the lead coefficients, and that's what your horizontal asymptote would be. But if the numerator degree is greater than the denominator, you don't have a horizontal asymptote at all. You have an oblique, which is a slant one. Okay, so let's look at some of these problems here we got for us. First thing we have here is, what's the domain of this and what's the range? Or well, we have to figure out a vertical asymptote and a horizontal asymptote. So on this, down, what makes division by 0? Well, just x. So my vertical asymptote, 0. X would have to be 0 here. That would make division by 0. So there's my vertical asymptote. Now the horizontal asymptote, what's the degree in the numerator? Well, there is no x up here, so it's 0. What's the degree in the denominator? Well, that's x to the 1 power. So the bottom is bigger. All right, so if the degree in the denominator is bigger, which it is here, it's y equals 0. That's my horizontal asymptote. Okay, it's a y, not a 4. All right, so that means these are my vertical asymptote and horizontal asymptote. I've got to take those values out of the domain and range, like right here, negative infinity to 0, and then 0 to infinity would be my domain. My range would be the same thing, negative infinity to 0, 0 to infinity. Okay, here let's look at one a little different, right here. All right, what are the equations of the vertical and horizontal asymptotes? All right, right here, if you notice, what does x have to be to give me 0 in the bottom? X would have to be 7. So that's my vertical asymptote. Now my horizontal asymptote, the degree in the top is 0 because there's no x here. The degree in the bottom is 1, so the bottom's bigger. So if the bottom is bigger, it's y equals 0. So y equals 0, but then I got this plus 6. So y equals 0 plus 6, y equals 6. This would be my horizontal asymptote. see this 6 is going to move it up some. Okay, number 3. Now, if this was my vertical asymptote, then my domain there would be negative infinity to 7, and then 7 to infinity. Okay, and then same kind of thing for my range here. My range would be negative infinity to 6, and then 6 to infinity. All right, this says identify the graph with this domain. That's the domain. Well, that means x equals negative 7 is my vertical asymptote. So all I have to do is I have to look at these graphs and see which one has a vertical asymptote negative 7. Well, it looks like it's right here. This one. Okay. Now, identify the graph with the range here. All right, so if this is the range, it means y equals 5 is my horizontal asymptote. So I just look for the, right here, this one. There's 5 right there. Okay. Number 5. Use these graphs to give all possible answers. All right, which choices have the x-axis as the horizontal asymptote? Okay, so if you look at this one, all right, here's my horizontal asymptote right here. That's the x-axis, so that one looks like it is. Now here's my horizontal asymptote right there. That's not the x-axis, so that's not that one. And we have the x-axis here, and we have the x-axis there. All these are rational functions. Okay. Now on this one, explain how this function right here can be obtained from this function right here. All right, all I'm doing is, since that's 5 instead of 1, I'm multiplying by 5 is what I'm doing. So this is a stretch. It's going to be vertical by a factor of 5. Okay. Now what would this look like? Now when this stretches it, now I didn't tell you this, but usually, okay, usually when you have this function here, okay, it's going to be a graph that looks like this. Usually it's where they're both negative and they're both positive, like that right there. Okay. So if you have a multiplier, like suppose this is stretched by 9, and what that does is it pulls this out and pulls that out, and that's what the stretch does. So if you look at this, see, like these are in the wrong spots here. This is, see, this part's right here and right here, so this is not even right. This in the same way. All right, see this? Here's this part right here and this part right here, and see how close they are to the axis? See how this is the same thing here, but they're kind of spread out, they're pulled out this way? This looks like my answer right here. Now the way you can tell maybe a little better, if you let x be 1, 5 divided by 1 would be 5. So at 1, this should be up 5, which it kind of looks like it is. And then the domain, all right, my vertical asymptote, we didn't do that, did we? X equals 0. 0 would make me divide by 0. So my domain be negative infinity to 0, and then 0 to positive infinity. My range, all right, it's y equals 0 is my horizontal asymptote, so it's going to be the same thing. Okay. Now this down here is asking about increasing and decreasing. All right, if you look at this graph, as you go from left to right here, this is going downhill. That's decreasing. Over on this one, if you start left to right, it's going downhill. So increasing, there's no interval, it's increasing. But now decreasing, it decreases on this part right here, and it decreases on that part. These are two different parts. So when I put this on here, I gotta go negative infinity to 0, it decreases there, comma, and then from 0 to positive infinity, it decreases there. Okay, I don't do a union in that sense. I just put a comma. Okay. All right, explain how this graph can be made. How this graph can be made from that one. All right, well, if you notice, I'm adding 1 to my x down here. And anytime you add or subtract to your x, that's going to move it horizontally. Okay? Which means x equals -1 is my vertical asymptote. So basically what happens is this thing has shifted to the left. So shift the graph of this to the left 1 unit. Okay? And then, well, there's no graphs here to choose from here, but if I was to show this, my asymptote should be right here to the left 1, and then it should be down here and up here like that. Okay, and then increasing and decreasing just like we did a minute ago. All right, this one has the graphs on it. I don't know why that one didn't print the graph out. Okay, now if you look at this one, how do I get this from that? All right, well, if you notice, I got the 1 over x. What's different here is the +9. Well, that's going to shift it vertically, which means my vertical asymptote is going to be y equals 9, +9. So you're going to shift, you're going to shift the graph horizontally. Horizontally, it's vertical. It's a vertical. I put vertical asymptote. This should be a horizontal asymptote. I wrote the wrong thing here and I confused myself. This is a horizontal asymptote. It's y equals 9, which is horizontal, which means it's shifting vertical. Let me explain that now. Normally, my asymptote's here, but this thing has shifted it up to here at 9. So my vertical asymptote shifted vertically, but it's still a horizontal asymptote. Okay, my horizontal asymptote shifted vertically, which is still a horizontal asymptote. Okay, I hope that makes sense. It shifted up, vertically up 9 units, which means now the graph, it looks like this one. See how that's up 9? See, this is down 9, and this moved to the left, and that moved to the right. And then, of course, your domain, all right, my domain's -infinity to 0, and then 0 to infinity. Because, see, I've got my vertical asymptote at 0. But now my range would be -infinity to 9, and then 9 to infinity, because my horizontal asymptote's way up here at 9. Okay? And then, of course, increasing and decreasing like we just did a while ago. This is never increasing. It's decreasing from -infinity to 0, and then from 0 to infinity. Okay, now let's match this one. Okay, so if you look at this right here, when does this equal 0 on the bottom? X equals -4. So this right here would be your vertical asymptote. Does that have it here? All right, good deal. Okay, look at 10 here. Now we've got several to choose from here. All right, so if you look at my vertical asymptote, when does this equal 0 here? -6. That's my vertical asymptote. All right, this says vertical asymptote -2. I don't see that one on there. Okay, what about my horizontal asymptote? The degree in the top is 0, the degree in the bottom is 1. All right, so the bottom's bigger, so it's y equals 0. That's my horizontal asymptote. Okay? So the x-axis is the horizontal asymptote. Okay? All right, number 11 here. What's this one? Okay, my vertical asymptote x equals 2. Okay, 2 minus 2 would make me divide by 0. Vertical asymptote x equals 2. That's right, isn't it? Oh, wait a minute. Oh, wait a minute. I almost made a mistake here on this one. All right, look here. This is what you got to watch out for. This on the top, x squared minus 4 is x minus 2 times x plus 2. On the bottom, I got x minus 2. And see how those will cancel out? they'll cancel each other out, which means this is just going to make a line. This is going to make a line of x plus 2, which look here. It goes up 1 over 1. It's going to be a line that looks like this right here. Okay? However, right here when x is 2, there's going to be a hole in this line. And there's going to be a hole in the graph at x equals 2. So you got to watch out for these, and they'll sneak up on you. If your degree in the top is bigger than degree in the bottom, you're not going to have a horizontal asymptote. And you're going to have to divide them down. Well, this one here divides out and cancels. So that means you're going to have a hole at that value. Okay? We may have another one like that in a minute. All right, what about this one? Okay, my vertical asymptote. All right, let me show you this real quick. Finding zeros. Okay, I may have done this before, but if you have these factors like x minus 3, 2x plus 1, 4x minus 7, 3x plus 5, 9x minus 8. All right, if you have these factors, right here my 0 is going to be 3. 3 minus 3 would be 0. Okay, what if I have this one here? All right, well, what you do now is you're going to subtract 1 and divide by 2, so it's going to be negative 1/2. On this one, you're going to add 7, divide by 4, so it's going to be 7 over 4. This is going to be negative 5 over 3. This is going to be positive 8 over 9. And this is how you can find your zeros real easy. This number over that number, but it's got to be the opposite. So it'd be positive 7 over 4. That's how you can find your zeros real quickly. So like on this one right here, oops. On this one right here, it's going to be negative 6 over 4, which is negative 3 over 2. That's my vertical asymptote. So this is negative 3 over 2. Okay. Now it says here, what's the equation of the horizontal asymptote? All right, my degree in the top is 1. My degree in the bottom is 1. All right, this is the first one like this we've had here. Okay, where the degrees are the same. So when the degrees in the top and the bottom are the same, you divide the lead coefficients. So my lead coefficient in the top is right here, negative 4. My coefficient in the bottom is positive 4. So I divide those, which is negative 1. So on this one, y equals negative 1. Okay? And then there is no oblique asymptote. You either have horizontal or oblique. You either have one or the other. You can't have both. So if you have a horizontal, you don't have one of these. If you don't have a horizontal, then you have one of those. Okay? All right, what about this one here? Give the equation of the vertical, horizontal, and oblique. Okay. All right, now this time, see how we got x squared over x here? But this doesn't factor out, so we're not going to have the hole like we had a while ago. You got to check and see if this factors out, and it won't. All right, so in the bottom, what value makes me divide by 0? Negative 5. That's my vertical asymptote. Negative 5. Okay. Now, what's my horizontal asymptote? All right, see my degree in the top is 2. My degree in the bottom is 1. Okay, look here now. The degree in the numerator is bigger than the degree in the denominator. So I don't have a horizontal asymptote. I got an oblique. All right, so there is no horizontal asymptote. This equation has an oblique asymptote. Now, what is the oblique asymptote? We got to do this division right here. Okay, so we got x squared, 1x squared, plus 1x minus 7. And I'm going to divide by this. All right, see, this is x plus 5, so my 0 will be negative 5. Okay, so 1 comes down. Negative 5 times 1 is negative 5. I add these, which is negative 4. Negative 5 times negative 4 is 20. I add those, which is 13. This is my remainder, so that really don't matter. But right here is what I've got, okay, which is what matters. And it looks like I'm going to have 1x minus 4. X minus 4, that should be my oblique. Okay. Okay, the answer doesn't look right on this from what I got the answers over here, but I did my division right. Oh, no, I didn't. No, I put a 1 there. That's what my problem is. There was no x. I don't know why I put a 1 there. So that'd be -5. So this is what the answer has. I just put that 1 there for no reason at all. I'm sorry. I probably confused you. But there's no x, so I put a 0. There's an x squared, there's 1x squared, there's no x, and then I have the -7. So this is going to give me this is going to give me a 25, which would be a 18 here, but the remainder don't really matter. So there's my oblique equation, x minus 5, 1x minus 5. I'm sorry I made a mistake on that. Oh, okay, now look at this one. Give the equations of any vertical, horizontal, or oblique asymptotes here. Okay, so what I need to do is right here, I need to find my zeros for this. Now you can factor this, or you can do quadratic formula. Let's see here. I'm looking for a piece of paper. Here's one. X equals negative b plus or minus a square, b squared minus 4ac, all over 2a. All right. All right, so my a in this problem is 2. Okay. My b is -1. And my c is -21. So I've got 2 negatives, which makes a +1. 2 times 2 is 4 down here. And then here I'm going to have, what is this, 8, 169. I got the square root of 169, which is 13. So I got 1 plus 13, which is 14 over 4, which is 7 over 2. And I got 1 minus 13, which is -12 over 4, which is -3. All right, so here's my zeros. Okay. Which means this thing has 2 vertical asymptotes. X equals 7/2. X equals -3. I've got 2 vertical asymptotes on this. Okay. What about my horizontal asymptote? All right, my degree in the top is 2. My degree in the bottom is 2. All right. They're the same, so you divide your lead coefficients. So my lead coefficient up here is 1. My lead coefficient there is a 2. So it's going to be 1 divided by 2, which is 1/2. And then there is no oblique. Since we have a horizontal, we don't have an oblique. Okay. What about this one? Give the equation of vertical, horizontal, oblique asymptotes. All right. We got x squared plus 5. All right, look here. X squared plus 5. If you set that equal to 0, I would minus 5. So I got x squared equals -5. And this is going to be imaginary. So there are no vertical asymptotes here, because there's no way to have a 0 in the bottom. There's no way on earth this could equal 0 down here. If you think about it, like if I put 0 for x, 0 squared plus 5 would be 5. If I put a negative for x, -1 squared would be +1, plus 5 would be 6. There's no way this would be 0, so there's no vertical asymptote. Now your horizontal asymptote, well, look here, my degree in the top is 2, my degree in the bottom is 2. They're the same, so I divide the lead coefficients. 7 divided by 1 is 7. And then there's no oblique. Since I have a horizontal, there's no oblique. You can't have both of these. Okay, here's another one. All right, let f be the function whose graph is obtained by translating the graph of y equals 1 over x to the right 4 units and up 2 units. Okay, so that means I'm going to have this. I'm going to have y equals, I'm going to go to the right 4 units, which means I'm going to have down here x minus 4. Since I'm going to the right, I have to have negative 4, which is the opposite. But then I'm going up 2, which means I'm going to have plus 2 here. Okay? Now, if you notice, write the equation for f of x as a quotient of 2 polynomials. This is not a quotient of 2 polynomials. So what I'm going to have to do here, okay, get another piece of paper here. I need to get a common denominator for this. I need to get a common denominator here and get it all concise with 2 polynomials, a quotient, which means I got 1 over x minus 4 plus 2 over 1. I need to multiply top and bottom by x minus 4 on this one term here. So I've got 1 over x minus 4 plus, so I distribute here, 2 times x will be 2x, 2 times negative 4 will be negative 8, and then 1 times, and there you go, now I've got common denominators. So that means I can put the tops together. So 1 plus 2x minus 8, but 1 plus negative 8 would be negative 7, so it's 2x minus 7. And that would be it there. So see, it's 2 polynomials. It's a quotient, which means you're dividing 2 polynomials. Okay, and that's right. That's what my key says. Alright, so that would go here. 2x minus 7 over x minus 4. Okay. Now, it says determine the zeros. All right, the zeros is when you have 0 on the top. So we just talked about that a second ago. It's going to be positive 7 over 2. Positive 7 over 2. Okay. The equation of the vertical asymptote, down here in the bottom, x can't be 4, so x equals 4 is my vertical asymptote. And then my horizontal asymptote. Okay, horizontal asymptote. All right, so the degree in the top is 1, the degree in the bottom is 1. They're the same. So when they're the same, you divide the lead coefficients. So I'm going to have 2 is my coefficient on the top, 1 down here. 2 divided by 1 would be 2. So there's my horizontal asymptote 2. Okay, let's look at this one. Which of these functions has a graph that does not have a vertical asymptote? Does not have a vertical asymptote. It's going to be the one like we talked about a while ago, right here. There's no way you can get 0 there. No way. X could be 0 there. This could be 0. This could be 0, but there's no way this could be 0. So get this in mind. X squared plus a number. X squared plus a number is never 0, which means you will not have a vertical asymptote. So that's like the problem we did just a few minutes ago. All right, 18 here. Identify vertical, horizontal, oblique asymptotes in the graph. All right, looks like my vertical asymptote's right here at 5. There's one vertical asymptote, x equals 5. There is a horizontal asymptote, it looks like 1, 2, 3. So y equals 3. And then domain, all right, my domain, I got to take this value out. So this is going to be negative infinity to 5, and then 5 to infinity. And that takes 5 out. Okay. Do a quick check on my answers here. Yeah, we're in good shape. All right, oh, okay, here's one. It's got 2 vertical asymptotes. All right, so here we go. Part B right here. There's 2 vertical asymptotes. The leftmost one is, this one right here, looks like it's negative 4, looks like negative 6. X equals negative 6. I put x equals on this. If you don't, you'll get it wrong. And then the rightmost one is, what is that, positive 6. X equals positive 6. Okay, my horizontal ones, all right, here's my horizontal one. It's down here at negative 4. So it has a horizontal asymptote, y equals -4. And the domain, all right, now look here on my domain. I got to take both of these values out. I'm going to write my domain right here. I got to take both these values out, which means I'm going to go -infinity to the leftmost one. And then I'm going to go from the leftmost one to the rightmost one. And then I'm going to go from the rightmost one to infinity. Okay, and that would be my domain. All right. Ooh, look at this graph. See how this one has no vertical asymptote? All right, so there's no vertical asymptote here. Okay. The horizontal asymptote looks like it's right here, man. What is that, -5? All right, I already got the y equals. You see that? Y equals -5. And then oblique, there's no oblique. You can't have horizontal and oblique, so there's no oblique. And then the domain says state the domain. Well, -infinity to +infinity. There's no vertical asymptote, so it goes from -infinity to +infinity. All right, what's the graph of this one here? Let's get them all on there. Well, first of all, x equals -7. That's my vertical asymptote. All right, so it looks here like -7. That looks good. This is -7 right here. That's not it. And that's not it. Now this one could be it right here. See that? So it could be that one. All right, so as far as my vertical asymptote, we got two options there. What about my horizontal asymptote? Well, the degree in the top's 1, degree in the bottom's 1. So they're the same. All right, so they're the same, which means we divide. They're the same, so it means we divide our lead coefficients, which means I've got a 1 here, divide by 1 there, y equals 1. That's my horizontal asymptote. Okay, so it's +1, which it looks like it might be this one here. See, there's +1. See how this approaches it there? Yeah, see here? +1, this crosses it. So that's not right. So it's got to be A. All right, choose the correct graph here. We've got a few of these, man. All right, so my vertical asymptote looks like x equals -1. All right, so this is +1 here. Now this looks like -1, so that could be that one. And this looks like -1, could be that one. But this one looks like +1, so it's not that one. Okay. Now my degree in the top is 1, degree in the bottom is 1. They're the same, so I divide 1 divided by 1 is 1. My horizontal asymptote, y equals 1. So y equals 1 would be here, and that one crosses. It's got to be this one. Yep, see, there it is. All right, what about the graph of this one? Okay, my vertical asymptote, 12. 12 minus 12 gives me 0. So 12 is over here. This ain't it. It could be this one. Could be that one. Not this one. See, this is like -12. All right, so if you look at my horizontal asymptote, the degree in the top is 1, degree in the bottom is 1. They're the same, so I divide. -3 divided by -1 is 3. All right, so it looks like this one here. That looks like 3, whereas this one down here looks like -3. Okay. Now, what about this one? Okay, now pay attention on this one here, because this is going to take a little bit more time probably. So first I find my zeros for this. Okay, this is going to be 5 and -3, I believe. 9 plus 6 is 50. Yep, these are my zeros right there. Which means at +5, or here's +5 right there. This is not it. +5 right here. This looks good. -3 right there. This could be it. +5 and -3. It could be this one. +5, -3. All right, it could be that one. As far as your vertical asymptote, this one's the only one ruled out. Now my horizontal asymptote. The degree in the top is 1, the degree in the bottom is 2. The denominator is bigger. So it means it's y equals 0 automatically. So y equals 0 is my horizontal asymptote. Okay. Well, here's y equals 0 right here. This is out. Alright, here's y equals 0, and this looks like it could be. And so does that one. Alright, so we've got two culprits here. So now what we're going to have to do is we're going to have to stick a value in. And so I think what we're going to try to do is right here where 5 is, if you notice, like if I went to 4, look at the difference here at 4. See how this is below 0? But at 4 here, it's above 0. So what I'm going to do is I'm going to plug 4 in my function and see which one I get. I get something greater than 0 or something less than 0. So I'm going to do the function value of 4. Okay? Again, my vertical asymptote is 5. So if I do 4, it's going to be above 0, which would be this one, or it's going to be below 0, which is that one. Alright, so if I put 4 in the top here, 3 times 4. In the bottom, I'm going to have 4 squared minus 2 times 4 minus 15. Alright, that's going to give me 12 over 16 minus 8, which is 8 minus 15 is negative 7. It's negative. So it means at 4 it should be below 0. This is not right. It's this one. Because see, at 4 it's below 0. So the answer is D. Okay. Alright. 25. We're getting there. Same thing. Pick up the right graph. Alright, now look here in the bottom. X squared minus 9, x equals 3, x equals negative 3. We got two vertical asymptotes. Alright, so negative 3 and 3, that looks like it. Negative 3 and 3. This looks like it's negative 5 and 5. That's out. Negative 3 and 3. So I got 3 possibilities here. That one's out though because it's at 5. See, my vertical asymptotes are at 5 and negative 5. So that's out. Alright, my horizontal asymptote. Okay. The degree in the top is 1, the degree in the bottom is 2. The bottom is bigger. My denominator is bigger, which means automatically y equals 0. Okay, so this one looks like it's good. This one looks like it's good. Dang, all 3 of them look like they're good. Alright, so that doesn't help us any. Okay, so now I'm going to have to do the same thing I did a while ago. So, okay, now look here. When I'm at 3 here, okay, if I go to 2, see how this is below? If I go to 2, see how that's above? And if I go to 2 here, it's below. So these two are both below at 2. This one's above at 2. So we're going to plug 2 in. So I've got negative 5 times 2. And then down here I got 2 squared minus 9. That's going to give me negative 10 over negative 5, which is negative 2. Okay. So that means this one's out. See, at 2, that's positive, where it should be negative. So this one's out. But see, at 2, it's negative. At 2, it's negative. So it's still down to these two here. Okay. Now, find another difference that you can decipher between these two here. Well, if you notice, if I go on this side 3, like at 4, see how this is above there? But at 4, this is below. See the difference here? At 4? At 4 here, it's above. At 4 there, it's below. So I'm going to do f of 4. Okay, I'm getting another piece of paper here. I'm going to do f of 4. So on the top, I got negative 5 times 4. On the bottom, I got 4 squared minus 9. So I'm just plugging 4 in my function. That's going to give me negative 20 over 16 minus 9 is 7. That's negative. You don't have to figure out what the value is because it don't matter. It's just negative. See, negative 20 divided by 7 is negative. Which means, got to be this one. Because see at 4, see how that's negative? Whereas here on 4, it's positive. That's not it. It's A. 25 is A. Well, darn it. It says it's B. I must have made a mistake here somewhere. Let's go back and look at B here. What? When I did this 2, negative 10. Oh gosh, man. Negative 10 divided by negative 5 is positive 2. So this was right. Dang it, I made a mistake. This was right a while ago. I freaking wrote negative 2 instead of 2 over here. So this was right a few minutes ago. So I probably confused you totally. Alright, so if you rewind back to this, when I did this a minute ago, and I wrote negative 2 instead of 2's, because that's 2, negative 10 divided by negative 5 is 2, not negative 2. This should have been that one. Alright, let's go to 26. Sorry about that, guys. Okay. Alright, this is good because it's factors. So like right here, x equals negative 2, x equals 5. These are my vertical asymptotes. Alright, so if you look at the graph here, I've got one at negative 2, which looks like this, and 5 looks like that. This one looks okay as far as my verticals. Negative 2 and 5, it looks okay. Negative 2 and 5. Negative 2 and 5. Freaking all of them, man. Whew. Now, my horizontal asymptote, the degree in the top, well, this would be x times x would be x squared. This would be x squared, so it's the same. So my lead terms, 1 times 1 is 1. 1 times 1, see, this is 1x and 1x, so if I multiply those, I have 1x squared. So anyway, 1 divided by 1 would be 1. So y equals 1 should be my horizontal asymptote. Okay. Now, I will tell you this. Since my horizontal asymptote's right here at 1, okay, this one looks like it crosses right here. Now, the middle can cross. See, these middles will cross, but the outer ones can't. So this one looks like it's out with my horizontal. And this one looks like it's okay. See at 1, see how this has crossed the axis right here and it's headed towards the 1 there. And I don't know about that one, man. This looks like it's got a horizontal asymptote of 0. And so does this one. This looks like, I think it's this one, B. I think this has a horizontal 0 and that has a horizontal 0. See the answer. Yeah, it's B. It's B. 27. We're getting close to the end here. Sketch this one. Alright, so like right here, we're going to solve this. You can do quadratic formula or you can factor it either way. On this one, we're going to have x equals positive 7. And we're going to have x equals negative 5. These are my vertical asymptotes. 7, negative 5. Alright, so here's negative 5, and that looks like 7. Negative 5. Alright, look at 7 right here. Out. You don't have a asymptote at 7. Negative 5 and 7, so that one looks okay. Negative 5 and 7. Alright, all three of those look good as far as the vertical asymptote. Now, what about my horizontal asymptote? Alright, the degree in the top is 2, the degree in the bottom is 2, so I divide 2 divided by 1 would be 2. That's my horizontal asymptote. Alright, so y equals 2. Well, look here, man, this is like at negative 2. That's out. Look, this is like at negative 2. Here's one at 2 right there. There's my answer, D. So the answer is D. Yep, that's right. Alright. 28. Graph the rational function. Alright, it says choose the correct graph. All right, we're not going to be able to do that one because it's on there. Let's go to 29. Graph this rational function. All right, look here. Notice this. There's no 0 here. So there's no vertical asymptote. So this one's out because those have vertical asymptotes, and this doesn't have it. It's going to have to be one of these two. So now how do you decipher? Well, I would say right here at 0, when x is 0, see how this is negative, but this is positive? So I'm going to do x equals 0 in here. So f of 0. I got 5 on top. I got 0 squared plus 4, which is 5/4, which means this one, not that one. Okay, the answer's A. It's right. One last one. Graph the rational function. Okay. All right, so my vertical asymptote, x equals -4. Okay, this looks like +4. This one don't even have one. All right, here's -4. Here's -4, so it's one of these two right there. Okay. Now, my horizontal asymptote, the degree in the top is 2, the degree in the bottom is 1. Uh-oh, look here. My numerator is bigger than my denominator, which means we do not have a horizontal. We've got an oblique. There's an oblique asymptote here. Okay, so which oblique asymptote is it? All right, so here's what we're going to do. We're going to take the top and write it out again. X squared plus 7 over x plus 4. We're going to divide this. All right, so it's going to be 1x squared plus 0x plus 7. And then down here I'm going to put -4. Okay, so I put my 0 for this, which is -4. This is 1x squared. There's no x. And then I have a 7. So the 1 comes down. -4 times 1 is -4. Add these, -4. -4 times -4 is 16. Add those 23. This really don't matter. But here's what I got right there. 1x minus 4. This is the equation. Oops. This is the equation of the oblique asymptote. I don't know why I keep writing G's here, but it's supposed to be a Q. Oblique asymptote. Which means it crosses at -4. It's got to be this one. See, here it crosses at -4. I think it goes up 1 over 1. It's got to be C. See, this crosses at +4, looks like. That's not it. It's got to be C, and C's right. Okay, so that's it, man. Rational functions. If you have any questions, let me know. Holler at me. Have a good rest of the day.